but I want to make it stable, I want to build a house on it. So now the demand is that. So there comes the optimization tools, optimization techniques from mathematics side, that if my factor of safety is 0.9, less than 1, it is unstable. But how to get the factor of safety at 1.5? What is the requirement of Bureau Standards code? That whatever you design, you have to design at a factor of safety of 1.5. So if it is a hill slope, there is no toe support, you will first design a retaining wall. Put that retaining wall in your numerical modeling and see how it is improving. Still, there is some problem, you have to put some drainage pipes. You take out the water pressure. If the stress due to water pressure is reduced, again your factor of safety increases. So with this sort of combinations, you optimize the solution for making it stable, making it a developed hill slope, or putting some infrastructure on it. And the second is mitigation model, what I was telling about, the control measures or implementation of control measures. And finally, when you make it stable, still you have to measure it, whether I am successful or my optimization has some problem or my design has some problem. So you have to monitor it. Whether really you are successful, you are addressing there is no movement at all, then you can confidently say that yes, my optimization solution is correct. So that's why you need a instrumentation monitoring or measuring certain parameters prior to implementation, optimization, and after optimization also. So that this completes the risk reduction model. And this sort of management system, whether it involves civil engineer, geotechnical engineer, mathematician, computer science people, or anything, electronics people, electrical people, together, this should be an integral part of our infrastructure development. Till date, since last 15 years, I am struggling to convince, now it has seen the day, in every forum I told this thing, that if I am making a road, it's not the road only. In a hill state, it's what is above the road, what is below the road, that is my responsibility. But you take border road or PWDs, then we have to maintain the road. Whatever comes, we will throw it into the valley. My road is perfect. So that was the attitude. But nowadays, you take example of NHAI, Highway Authority of India, or NHIDCL, that is National Highway Infrastructure Development Corporation. Everybody is considering taking hill slope management system into road infrastructure, into rail infrastructure. Now we are planning Badrinath will be facilitated with the rail. And I was traveling in Gangtok on 1st and 2nd of February. I see that they are facilitating with a rail network to Gangtok. And see what is the development model. If rail will reach there, the local people, what they are producing, they can come down to West Bengal and sell their product and go back on the same day. So we are developing the economic condition of a common man, a common people. So infrastructure has to come, but this integration also is very much required, very much necessary. So coming to the vulnerability or risk assessment part, but I was telling that we have to look beyond hazard or susceptibility zonation. That was only talking about spatial prediction. But we have to, if we predict that hazard will occur here, what we are doing, that knowledge has to transfer to the society. So what we are doing for the society, it's not about a research publication. Now the thing is, whatever research or integration you do, it should be translational. The product has to go to the field, go to the society. So in that direction, Your hazard was, what is the hazard? How severe is the hazard? That part we are covering and where it will occur. But vulnerable is who is vulnerable, to what extent it is vulnerable, whether it is infrastructure, building infrastructure, road or rail network or hydropower project or the human life itself. When you are talking about a house, if house is under risk or it is vulnerable to a disaster, so the life is always at risk. And even people are talking about daytime risk and nighttime risk, because daytime people are away from their house, so life risk will be less during daytime, but nighttime people are inside the house, so the life risk will be more. Okay. And then finally the risk assessment. So the vulnerability, we have 4 categories. Any infrastructure, here I will take example of a building infrastructure. So the physical vulnerability of that particular infrastructure, losses or damage to that structure. Then environmental vulnerability, that is loss of natural resources like water, land resource like Josimatter. There are environmental vulnerability also, because we lost many land resources, though we had physical vulnerability also. Then social vulnerability, loss in popular social structure. It made our mindset imbalance. The people are disturbed. People, the whole life they earn something and convert it into a house. But the house is damaged, so next day they are houseless. They don't have a place to live. So that sort of social or economic status people are facing. So here I will talk about physical vulnerability, because there also application of mathematics. Any field you name, without mathematics it cannot sustain. Now mathematics is in every branch of science or arts or engineering. So there are different methods people have used in global scenario, but I will talk about the indicator based approach, because that's really a practical aspect or practical approach. And there are research gaps. I will not go into detail. That India, we have special prediction only. We are not bothering about vulnerability. There is no standardized methodology. We have to develop that. They assess in European countries. It is existing, but not in Indian scenario. Then the greatest setback while we are struggling is the database. We don't have a proper digital database where we can claim, where we can. So we are struggling that nowadays. That's why the digital India or digitalization of everything is being happened, because we have to create a strong database. What is your strength only? That mathematicians without database they cannot play, they cannot think even. So you need a proper database of anything you name. Without that, we are handicapped. Okay? So that's one aspect of it. Then coming to risk assessment, it is required for practical applications, because our knowledge has to be transferred to the ground. So that's required, and it's a measure of hazard and vulnerability. Hazard is the intensity or severity of a disaster or a hazard we know, and we know how that will affect our infrastructure or the society, the community, and integrating these two, the severity or intensity of a hazard and the vulnerability of our infrastructures, integrating these two will reach at what risk level we are living. Okay? So there are certain issues what we are going to resolve. So this is the methodology we have developed. I had a PhD student from civil engineering background, and I am a landslide expert. He had some knowledge on mathematics. Like you are doing faculty development program, so maybe any faculty member from any stream can join this and integrate their knowledge. So that's why I used his civil engineering knowledge and I integrated my landslide expertise. We developed this model. Now it is getting famous, getting popular through citations, and people have started working and thinking in that direction. And Ministry of Home Affairs is going to launch a 1,000 crore project based on this. That project has been designed by me when I presented before Home Secretary, and it is through, because of election it is getting delayed. April it will be launched worldwide. All the state disaster management authorities will be funded for taking up these issues. Earlier it was landslide centric, that there is a landslide, we have to mitigate it. No, we stopped that business. It's not landslide centric, it is habitation centric. Because we have to address the problem of the people, the risk to life of the people. So take a hill city, take a hill village, relate it with earthquake or landslide and give a solution and develop that their standard of living or their safety aspect of to their life. So that's the approach, and I'll show that what is that. So we can collaborate. Actually, today is the day of co-innovation, collaboration or co-development. Single-handedly, no researcher can do anything, or any academicians. You have to integrate different knowledge, give a holistic solution, end-to-end solution. Earlier it was, my area is in geology, so I will think in that direction. On the same topic, mathematician will do something else. We are never integrating, but now the country demands integration. Only the multidisciplinary projects are being funded, not single stream projects. So, and the end product is very, very important, whether we are translating it to the society or not. So we have to keep that in mind while doing the project formulation. There are a lot of money available, and there are a lot of calls for projects, for project funding. Now, like by 10th February, Ministry of Earth Sciences has asked for disaster resilient India. That one project you have to submit maybe 3-4 pages, and that EOI, the expression of interest. They will evaluate your expression of interest. Then whoever is selected, they will call for the proposal. Now the thought process is shifting. Earlier we have to straight away submit the proposal. Now they are asking expression of interest. What is your thought process? Whether it is really required for the country. They will evaluate from this ground. Then they will ask, yes, your expression of interest is interesting, so you submit a project proposal. So like that, we are the process is changing. So here we have 3 pages. I have time up to one.
Sir, yes.
So in between you can interrupt me. It's not only a chitrahar sort of thing. It's not only about slides. You can interrupt. You can ask anything. We can have a discussion across the. Okay. So these are 3 phases. The first phase is to define the intensity of a landslide. That we call landslide hazard zonation or susceptibility zonation. The second phase is the vulnerability assessment, and the third one is the risk assessment. So we do hazard assessment, intensity, then we do vulnerability of infrastructure, integrating phase 1, phase 2. With the third phase we reach at risk assessment. So going into detail, I'll show all those phase 1, phase 2 in details. So the study area, we have taken a capital city of Chamoli district, that is called Gopeshwar. It's in the Badrinath highway. It's a big city, around 1,000 houses on a hilltop, and it looks like it's a very good city and very stable and very safe. But from my point of view, all surrounding slopes are prone to landslides. There are many slopes. So we are sitting on the top, but my foundation is going. So that sort of scenario in that particular city. So we take And this is the ideal city I am talking about. And you will find it's not only Gopeshwar, in Kerala, in Maharashtra, in northeastern states, Himachal, Uttarakhand, everywhere you will find number of cities like that. All are now vulnerable and the structures are 70, 80 years old. We have new developments and new RCC structures, so it's all a mess. We need to attain this progress.